Hello, welcome to the special CUBE conversation. I'm John Furrier, host of theCUBE. We are here in our Palo Alto studio. As you've been following, the AI infrastructure build out is continuing to go along, the investments in the CapEx and the token rage that's going on, the token maxing, anti-token maxing, the value creation happening in this market's happening at a breakneck pace, and the AI infrastructure investments are trying to keep up. NVIDIA, Intel, AMD, all the semiconductor companies and the software companies are following along. We got a great featured news story here around a new chip and new system, scale-up systems from Tensordyne. We have the founder and chief product officer here, Anand, who's here. Thanks for coming on. Legend in the industry, well known from your Juniper days. Thanks for coming down the road to our Palo Alto studio.
John, it's a pleasure to see you and a pleasure to be here at theCUBE. I've been a big fan of yours for many, many years, and it's an honor, and I'd love to tell you a little bit about Tensordyne.
Well, honor's mine, because I think what you guys are doing is super hot, because your innovation, timing of it, taping out, which is the news we'll get into, is very relevant. Yeah. Because the number one conversation is, how do I get the most out of the energy? Energy is bounding the value proposition in AI. Everyone's been talking about it. It's in the Maslow's hierarchy of needs in computer industry. It is the lowest level. We need that energy. You guys have a major piece there, but it's also a new chip. And everyone loves a new chip, because a new chip is, wow, a new chip is here. So in the semiconductor story, it's a chip, but what I love about what you're doing is it hits both the chip innovation, but it also hits the disruption on the economics.
It does.
Because everyone's talking about the CapEx, where's going to be the ROI? When do I see the coding and the agents coming in? How do I think about the architecture, the scale that's going on? Economics is the number one driver. This is not IT projects. This is essentially business. Like the router days.
It is.
When you connected companies, commerce happened, which we were involved in. So let's get into the news, because, and the company, you recently come out of stealth. You just had the news Monday around the chip. Talk about what you guys are doing, because I think this is super compelling.
Yeah. So, at Tensordyne, we announced our Napier system, and Napier is named after John Napier, a Scotsman who actually invented logarithmic math, or logarithms. And so we announced our 3nm chip earlier this week, and it implements log math. And when you do log math, you can actually convert multiplications into additions, and then suddenly the compute becomes denser. Along with our chip, obviously, we announced our TDN72, which is a 72 accelerator-based scale-up system. And so combination of all of these now puts us in a really good place for the world of agentic AI and the pace of tokens and token consumption.
So TDN is Tensordyne Napier.
That's correct.
Right? That's kind of the acronym.
That is the acronym.
I saw that in the presentation material. That's a rack scale system, a scale-up system. Explain what that is. You have the chip. Right. This is a system.
Correct. So if you think about it, a lot of the AI models in the last 6 months have become very, very large. And they are at the forefront of the momentum around coding and other things. So for these models to fit on a device, you actually need a scale-up system. And so we partnered with HP Juniper Networks and leverage one of their systems that has scale-up fabrics. And we integrate that with our compute engines, and that allows us to deliver these systems, which are 19 units racked, so they fit into any data center around the world, and they are air-cooled. And so they are the most energy-efficient AI inference systems in the world.
So inference, we're in the inference era, it's been called. I mean, I don't know who coined the term, but I think it's been generally talked about. Training was Gen 1, inference. Now you're starting to see training and inference kind of come together. Inference is where all the action is on reasoning. So when you hear Databricks talk about what they're doing and everyone else up the stack, they're relying on the reasoning.
That's correct.
This is where you're enabling that. And then at the same time, the AI seems to be moving from an accelerated AI to native.
Okay.
That's kind of my take. I want to get your reaction to that, because NVIDIA says accelerated computing.
Yes.
But accelerants have always been kind of like a bolt-on, like a turbocharge. This chip seems to be natively built for inference.
That's correct.
Is that correct?
That's correct. We have primarily built our system and our silicon for inference. And so we anticipated this would be the situation in 2026 and 2027, as we look at our architecture, which we started many years back. So the Napier system is designed for the world of agents, the world of coding, the world of inexpensive tokens that consume less power. But also run the biggest models in the world. And so that's how we have set up. And I think that we're at the early stages of this momentum around a broad use of AI. And so we believe we have a really well-designed Napier system that can serve the market very well.
In the brief and in the news, you claim 8x less power, 6x less floor space, up to 6x more revenue generation within the same data center footprint. That's a CFO story, that's a hyperscaler story, that's a data center story. It's kind of like checking all the boxes. Explain how you do that, because those are good numbers. Yeah. That's what everyone's trying to get out. Everyone's talking flops, yeah, tokens per second. That's not speeds and feeds.
Yeah.
That's cost. That's
it is. Yeah.
That's value.
It is value, it's economics. So if you think about it, for a long time we were always discussing speeds and feeds. But eventually what matters is the value proposition at the data center or the hyperscaler layer, where those providers need to see that whatever they deliver to their customers is economical and is beneficial to them. And while they do that, they make money. They're profitable in that. So our approach actually allows us to have those advantages because we start with the fundamentals. And a startup has to have some fundamentals, and our approach is with math. When we do math, we consume less power, and that allows our systems to be really, really efficient in the data center while delivering those high rates of tokens of the best models in the world.
So the market's talking about NVIDIA, Vera Rubin, and Grok, Trainium and Cerebras, and you guys have Napier. How do you compare? How would you describe your approach versus those two?
Yeah. If you look at the recent past, what has happened is that people want high token rates, tokens per second per user. Mm-hmm. That's a metric, which means that the speed of which the tokens come out of these systems are important because ultimately it's an indicator of productivity. So if you look at the recent past, what has happened is that disaggregated systems, where a system does prefill and a system does decode, has to appear from NVIDIA and Grok or from AWS and Cerebras, because their primary systems could not do the decode fast enough. So they had to put these systems together in a heterogeneous manner. Our system is designed to do prefill and decode incredibly well. So no matter whether you're doing a prefill exercise or a decode exercise with large context and a high-performing model, we do incredibly well. So customers now don't have to have mix and match. They don't have to have stranded capital. And then they can actually, they don't have any operational complexity and reliability issues with a single system.
Let's talk about the news. So official news is you've taped out the chip.
That's correct.
And you announce the racks.
Correct.
Explain what people can expect.
Yes.
What that means. Yeah. What's the benefits.
Yeah.
And the hard
Definitely.
news.
Obviously we spent the last 2.5 years designing the chip and getting it taped out to our partner Broadcom out to TSMC. So the chip is in fab at this point. We expect silicon back sometime in October, and we will power on our systems, and we expect to give alpha and beta systems to customers in Q1 of 27 and start shipping revenue production systems by Q2, Q3 of 2027.
What can we expect at that time frame? That's just like in AI years, we used to say the internet was dog years. That's going to be like decades. What are you anticipating from a performance standpoint? Just order of magnitude, what's the thoughts around that?
Yeah, so I think if you look at, one of the things you do when you design systems is to actually characterize it. You don't want to be surprised when the system shows up in the lab or in a customer hand. You want to know how well it performs. So we've done extensive simulation. We know where our system performance numbers are. And that's why our claims, we can stand behind our claims. Validating that and demonstrating that is super important. So when the system comes back, we want to demonstrate that to customers, and then they see the value proposition, and then they make buying decisions around it. And that's how we will approach.
Take us through some of the momentum. Obviously, the tape out's big news.
Yes.
We all know that once that happens, it's no turning back, point of no return. What's some of the engagements you have with customers, partners? Yeah. What's been some of the momentum?
Yeah, so we've spent the last year and a half actually doing all the groundwork to get ready for when our systems are ready in the lab or in customer hands. So we have over 13 letters of intent from a number of neoclouds. In addition, we have a fairly deep partnership with one of the largest hyperscalers. And so that...
so there's early interest, big time.
There's incredible interest because they see the value of the performance and the power characteristics and the fact that they can deploy them in existing data centers around the world.
So no real disruption to footprint.
no disruption of footprint, taking systems that leverage from Juniper that we are now repurposing for our needs, and then go into standard 19-inch racks in air-cooled environments. And so suddenly you can deploy them around the globe.
So no power cooling needed for these systems?
No extra power, no extra cooling. In existing data centers, we can slide in rather than having customers have to build grounds up liquid-cooled data centers.
And who are the investors? Take us through some of the early investors and who's in the deal.
Yeah. So we have obviously significant number of venture investors and then a strategic investor. So early investors were Great Point Ventures and Celesta Capital and Mayfield. More recently was Zora, which is an investor who has a deep relationship in a single LP in Temasek out of Singapore. And then Premji Invest was a more recent investor. In addition to that, HP Juniper Networks was an early investor in Tensordyne. And
that was Juniper before they
That's
had
correct.
the acquisition.
Before the HP acquisition, Juniper Networks invested in us, and we have a deep partnership with them. And they see the value of what we're bringing to the market.
You know, RK, I love the background, and I wanted you to tell your story around your history with Juniper, because I think, you know, I've been kind of yelling into the void. Networking is the key to success. The AI paradigm really is a networking and computing paradigm. Not like there's your compute, there's your network, there's your storage. You have this system design. It feels like the early days of PCs and servers and routers when you had to kind of build the box, pick everything integrated in, and manufacture it, versus like the homebrewed computer club, right? Which seems to be some of the AI approaches we've seen. Your background at Juniper was significant in this venture. Share your story on your Juniper history.
So I had the good fortune to join Juniper incredibly early. I was employee number 12, and I have to give all credit to Pradeep Sindhu, who was the founder of Juniper, who hired me. And so I had the good fortune to see that growth, right? See the company succeed. And why was Juniper successful was because the internet was doubling every 6 to 9 months in 98, 99. And UUNet, Mike Odell, who was CTO, said, listen, I need a router. I need more routers, and I need them to be higher in performance, and Juniper delivered that. I think we are in a kind of a similar situation now, where there's insatiable demand for compute, for AI, for inference primarily. And when that demand is in place, customers are saying, listen, I need something that's more power efficient. I need that is something that's performant, and that can deliver economic value to my business. And so I think there's a massive, massive opportunity. The TAM is going to be in excess of $1 trillion. So a startup like Tensordyne has a significant opportunity to capture market share.
And so I like the comparison to the doubling with the internet. If you remember those times, I mean, folks who weren't around then might not remember, but Juniper's product was very regarded as the high performance product.
It was.
So does that DNA come over here? Because you can almost say, hey, you had a view of the field, now you're in the arena, you're jumping in at the perfect time to build a killer product. So tell us about the product vision and your first principles around the product.
Yeah. So first principles, so first of all, to your point, I think networking is front and central in AI. Without networking, you don't have AI. So I think that's an important point.
And we hear model routing. They actually use the word router. Routing. So that's, again, to your point.
It is. And so I think our first principles were, if you do math the same way as everybody else, you're going to be undifferentiated. So think about, a startup has to think about what is revolutionary and what they can do to be differentiated. And that was our approach. And that gives us the power advantages that matter. The second is that our good fortune was a lot of us at Tensordyne have systems background, and we had the relationship and the knowledge of networking. And that was key. And so when we realized that we needed to put a lot of accelerators together, the light bulb went off. And we said, you know what, we know which networking capability we can leverage. And that was how that partnership with Juniper came about. And that way we could put these things together and have this world-class system come to play.
I want to get your thoughts on this, because in every computing paradigm, there's a point where you kind of max out, and then everyone's building and designing the next chip or the next system.
Yeah.
And you see things like offload. You see things like accelerators.
Correct.
We've seen that before. It almost feels like today's AI is a bunch of accelerators. And maybe that's maybe not the right view, but it needs to look at from a pure, clean sheet of paper. And I like that about Grok, because the founder was always about inference.
Correct.
From day one.
They were.
Highly optimized for that.
Correct.
You guys are on the similar thread.
We are.
Okay, so obviously NVIDIA buys Grok. So your relationship with the AI systems
Yeah.
is going to be what? How do you see Tensordyne integrating into all the compute, all the GPUs that are out there? How do you see that happening?
So you should look at us as just another system vendor going into a large hyperscaler or a data center or a neocloud. We will do the accelerated part of it. But with agentic workloads, there is orchestration. So imagine that the accelerated heavy lifting is done by systems like ours. And then CPUs and storage come into play because CPUs have to orchestrate. So it's almost like a conductor of an orchestra where the high power, high performance, high demand is done by AI compute, and the orchestration is done by CPUs, and the storage is an equally important layer that has to come in because user data, user information, answers from AI go into those systems. So I think that we will play a critical role in the deployment of inference at scale.
All right, so the question is this for you. Are you building a better chip or are you redefining the economics? How would you pick one of those?
I think we are redefining the economics of generative AI inference, fundamentally by starting from the ground zero and architecting this really well and getting it ready for the market of today and tomorrow.
Okay, in your preferred future, chip comes in the fall,
Yeah.
you get everything ready, Q1, you're out there.
Yeah.
What does that look like to you? What does success mean? Are you deploying systems? You're dropping into data centers, you're selling to hyperscalers, and they're integrating. What does that look like to you?
Yeah, it'll be a memory and a reflection of what happened in 98 and 99 at Juniper, is that when the customers see this, they will recognize the value, and then there will be a demand pull that we will have to somehow survive and deliver to the customers. Because in the supply chain, you have to plan this really well ahead, and we're doing all that groundwork today so that we plan for success in 27 and 28. We expect that our systems will be well received by the market, by our biggest customers, and then they will see incredible value of it, and then they will see the economic benefits that they will get from it.
Got it. Okay, so you've kind of been down this road before with Juniper, TSMC, similar thing now. All the rage is the manufacturing of semiconductors. What's different? If you had to look at, obviously the market's different and technology is different. Is it the same game, just different time? What's similar and what's different?
Yes.
Because you got all the things going on. You got the design's well done, you're hitting the right TAM, you got the relationship with TSMC, Broadcom. I mean, it's lined up.
It is.
So what's different? What's same?
I think what is different is our fundamental architecture approach and first principles approach to this, because you can't just do more of the same. What's different is that we think about the problem at scale from day one and think about it differently. What is similar is that you're still on the technology treadmill that everybody else is. Right? We will not have any distinct advantage over anybody else when it comes to getting TSMC 3 nanometer or 1.4 nanometer technology nodes. So the way you differentiate is by actually fundamentally rethinking the things from first principles and implementing them really well. That's what happened between 96 and 98 at Juniper. We had access to the same technology Cisco did. But fundamentally doing this really well and having an incredibly great team that thinks about all the dimensions that make a system possible, from silicon to chassis to software to applications, all the way through compilers, all of those things. So we have a great team that has all of those facets. We're a truly multidimensional team.
I love the deep tech angle on here. Great team. Love the market, as I just mentioned. Let's talk about the economics, because I love that answer, because that was, to me, that's a good answer, because certainly everyone loves chips, but when you get down to the disruptions, the economics.
It is.
Because let's talk about that. A lot of people are trying to put labels on metrics. I kind of hinted on the token maxing thing, but let's talk about semiconductor.
Yes.
Density is huge. You guys have a view on density ratio to value. Take us through how you see the value proposition. Obviously, smaller footprint. You can do more in your rack than other vendors. They have multiple racks, and then we're seeing people deploy a multi-rack strategy today.
Indeed.
They have to.
They have to.
So now you're going to shrink that down, compress that down.
Correct.
What's that look like? How do you define the metrics?
So the metrics are purely consumption driven. So when you look at hyperscalers or neoclouds, and let's assume all of us are consuming AI. Let's assume we are all using the latest model, say Opus 4.8 or GPT 5.5. That demand now forces these providers to rack and stack more and more. The question is, at a rack level or a chassis level or system level, can you deliver more tokens and can you consume less power? And if you do that better than anybody else, then the operators think that in the data center they can put more gear. That's usually we have a fixed power, and they can actually extract more revenue, and the customers will be happy because they get them at speed, high tokens per second per user. And so the metrics are pretty clear at the outset for us.
What's the problem? Because you have, the MOEs, you got the reasoning algorithms, you got the coding. Is the problem that the AI is always on and no one's actually figured out how to build this durable system? Or is it just they need smaller, faster, cheaper,
I think
like a Moore's law kind of thing going on here?
if you think about the virtuous cycle, things have to become less expensive and have to become more available, more ubiquitous. Then the consumption patterns change as a result of it. If we all need a superpower of AI, and we all demand that superpower, and we are using it, then it becomes essential that the system deliver that really economically and really well. And if you consume less power, then the footprint is better. The societies and the communities don't have to see large, monstrous data centers. These data centers don't have to consume a lot of water, and all of those benefits start to accrue. And then people start seeing economic benefit of AI. When they start seeing that, their lives become more productive, businesses become more productive, and it really helps them.
It's a great breakthrough. I mean, we can see a distributed architecture for sure. You mentioned disaggregation,
Yeah.
but there's also disaggregation of AI factories.
Correct.
You can have smaller housing around these data centers. You don't need the monster data centers.
Correct.
And it also opens up kind of the new kind of grid computing
It does.
in metro areas.
Correct.
Edge is
Correct.
going to be probably a hot area for this.
It will be, yeah. So if you think about it, let's assume that instead of putting gigawatt data centers, we can put small 10, 20 megawatt data centers around all large metros, around New York City or Chicago or Miami or the Bay Area or LA. Those become really valuable propositions because now you're delivering AI at low latency to end users. And in those areas, you have congestion, you don't have too much real estate, you have limited power. How do you do that?
Yeah.
And I think we will help that.
It's interesting, RK, I was at MWC, Mobile World Congress in February, and I had some chats with Verizon folks and AT&T infrastructure, the carriers basically,
Exactly.
not the infrastructure providers. They were telling me that the dormant power alone, that's disaggregated, because they really can't put big AI factories in their central offices or in their footprints. They're like, we could probably aggregate all that energy.
Yeah.
And you're connected to the internet, so
you
can talk to other factories. So you kind of have this new paradigm of networking
and
the intelligence and the compute.
Yeah.
What's your vision on that? Because we're kind of back to networking again.
So I think, pipes matter, right? Connectivity matters. And if you look at the Verizons or the AT&Ts or the Deutsche Telecoms or British Telecom of the world, they are located all over the globe. They have all these points of presence or central offices, and they have power there. They have cooling there. Why not put, AI inference compute in those locations without having them to do forklift upgrades of liquid cooling or all these other things?
Any retrofitting is more CapEx, just drop it in.
Drop it in.
They got power, they got a little building that connects the towers to the internet. They got plenty of room.
And they can now start offering those services to enterprises that need dedicated AI. So that means they don't want to be in a cloud, they want their data to be secure, and they want to use AI infrastructure, but they can't do it on somewhere in downtown in Manhattan, but they can get to an AT&T central office and they can have this AI right there.
Scope the size of the rack, because NVIDIA NVL72 is a big rack. It's a tall rack. How do you compare? Just half, quarter?
No, it's a quarter. So NVIDIA GB300 NVL72 is 150 kilowatts. It's a full rack height, and it probably weighs a few thousand pounds. Our chassis is 1/4 of a rack, consumes 30 kilowatts, which is 1/5 the power, maybe even lower in some situations, and delivers the same performance and the same level of tokens, maybe even some cases more. So just imagine now, it should be pretty clear to operators to see that this is a more viable and more economical solution.
All right, so the skeptics were going to say, okay, yeah, but NVIDIA is so ahead of everybody. They're going to come out with something else.
Yeah.
How do you answer that question?
Yeah, I mean, an exceptional company, a really well-led and well-run company, technology companies, right? And in Silicon Valley, we all look at ourselves as fraternities up and down Highway 101, right?
Yeah.
So we cheer on all other companies. They're good engineers there and building great stuff. I think the thing is that their approach has been for the last decade or more has been to use GPUs and have a training mindset, and it's served them incredibly well. But the world has gone from training to, let's say, good to have chatting to actually real work.
Yeah.
So shifting from fun AI to real work AI, real productive work AI, and that is inference with the largest models in the world. So suddenly it's like the internet going slowly and suddenly the internet doubling every 6 to 9 months. So you have a similar analogy, and so the demand and the pressure is for inference systems that are really purpose-built for the world of inference, purpose-built for large experts and mixture of expert models, and we are well set for that.
There's so much lessons to be learned from the original computer industry, which we were both part of. You were pioneering at Juniper. Is that interoperability and heterogeneous systems is key. Yeah. Open source then comes on the scene, which is great from the software side. But now even Open Compute, if it wasn't for the Open Compute project, there'd be no standard rack. So that's thank you, OCP. Talk about the role of heterogeneous systems, because if you have an x86 architecture, for instance, because that's the dominant platform, they're out there.
Yeah.
There's easy migration. You can just, a new chip comes out from Intel, AMD, or anyone on that architecture.
100%.
Gets better. It could also save money there too.
Yeah.
But you have a huge computing estate.
Correct.
Under x86.
Correct.
So with this kind of new trend, bolting in,
correct,
or not bolting in, or sliding in, as you say, takes advantage of that. What's your view of that? Because this is not really forecast on a lot of the analysts' radar. They think of it, NVIDIA is going to rule the world, ARM is ARM. ARM is great, but ARM isn't x86, it's not well deployed. People have to swap stuff out. Enterprises aren't going to just replace all their x86.
Exactly. So I think that, we'll coexist. I think x86 CPUs are critical to the whole AI effort, because like I mentioned, in the agentic realm, they actually play a critical role of an orchestrator. Accelerators cannot orchestrate themselves. They need somebody to orchestrate their work and give them work, and then the results of the AI machines come up to these orchestrating machines that pull and call different agents and different AI models. And so it's fundamentally coexistence. I think CPUs have an incredible role to play in the world of AI and the shift of to agentic AI.
Do you see Tensordyne and NVIDIA as accelerators or a separate thing? Because in a way, you are a new thing. You're not accelerating, you're accelerating the mission of AI for sure. That's just a verb.
It is.
It's not like you're not accelerating x86 or how should people think about it? Because accelerate just be, hey, I can't get enough out of my horsepower, let's accelerate it.
Yeah, I think that the way you want to think about it is that AI workloads are incredibly compute intensive, doing incredible amounts of mathematics, basically matrix algebra. And so what you want to do is pack as much of capability to do that really well. Of course, there's memory, there's interconnect, there's communication, all of those things. So that is the fundamental building block for AI. And so the more capable you are there, the more performant you're there, the better it is. But that's by itself. But tokens coming out or words coming out of a machine are insufficient to actually tell you what needs to happen in a spreadsheet, or how to make a travel arrangement, or how to schedule a customer support call. All of that has to be orchestrated. So there's incredible heavy lifting that's done by the AI machines, and then there's orchestration that basically tasks it. And I think both have to exist together.
Yeah, and it's interesting too, you're starting to see the different Pareto curves come out, and it reminds me of the early days of semiconductors where you had just, new processors come out, new chips come out, and it became like a product roadmap, entry level, mid-range, high-end.
Correct.
You started to have those segmentations. You can almost, now run policy and routing and saying, okay, these workloads are this intelligence that we need to reason on something or solve a big problem. Use the top.
Exactly.
High end. For basic, what's the weather in San Jose? I can use something else.
Indeed.
This is where the systems have to be smarter. You agree?
I would agree 100%. If you think about the largest models in the world, you need to run them in data centers because you need power and cooling and all that, and the biggest machines. But I would expect that some amount of work actually is done on devices like laptops, which have AI silicon in there. So there's a distribution of work where some of it is done locally, and then if you want to do some heavy lifting or you need more precision or more high accuracy, you'll push it to the cloud. So there's this coexistence that has to happen, that has happened in prior industries, in prior markets. I don't see that being any different here.
How would you describe it, and there's no real answer to this, I'm trying to get my head around it. We had computing, desktop computing, notebook, laptops, then notebooks, handhelds, servers, servers became cloud. Now the computing paradigm has changed because the servers come out first, the systems, the large scale systems or AI factories. Now you have announcements, so Dell, NVIDIA, the AI PC comes out after.
It does.
That's not the way it was before, so it's kind of inverted. When that's fully proliferated, I have my handheld, I got my notebook, it's connected, it's all AI.
It is.
What do you call that? what paradigm, what's the, like, I'm not stuck on the name, but it's a different paradigm. I'm trying to understand, how do you view that paradigm?
I think I view it from the experience of the user. So for the experience of the user, suddenly you have a far more capable laptop, but there's some division of labor where the laptop can and do certain amount of things, and then some of the work has to be done in the cloud. It happens with search today, right? We do some things on the laptop, we process, do a spreadsheet, and then we do something on the cloud with a Google search. So similar analogy will happen with AI, and I expect that that demarcation boundary will be more flexible. Now, why did it start in the cloud or in the data center and go there? Because the experimentation of AI first had to happen in big machines. The models had to get bigger. The models had to get more capable, and you had to do them in really large machines where they train across 100,000 GPUs. Once the models got better, then they realized we can make smaller versions of them and put them on your laptop. So that trend was directionally, I think, appropriate.
Yeah, and now it's just computing.
Now it's
in a way, it's client server, but everyone's connected to each other because you have resources that are going to offload tasks and then talk to each other. Again, back to networking. Okay, this is fascinating. Congratulations on the news, and congratulations on launching the chip.
Thank you very much.
And the scale-up system. What's your focus now? Put a plug in for what you guys are doing. I'm sure you're hiring. You have to kind of stay stealth and quiet. Now you're out.
We are.
You're hiring, obviously. Who you're hiring for? What positions? What kind of partnerships you're looking for? Put a plug in for what you're working on.
Thank you so much, John. So yeah, we are building our team. We continue to hire a lot more folks on the chip design, the silicon side, on the system side, platform software, and then we really need more engineers who are really good in AI, who understand math really well. So across this landscape, and then as we get into next year, we'll hire more into the go-to-market team in business development, in product management, and in customer support. So as a company gets to the stage, they have to put all of these functions in place, and we're going to do that.
And explain the architecture of your team, Germany and Silicon Valley. Talk about that, because that was intentional from day one.
It was. From day one of the company, we set ourselves to be a bicontinental company. In Silicon Valley, our core teams do the silicon design, the system design, platform software, and some of the staff functions are here. And then in Munich, Germany, we have an exceptional young team that does math, and they do math really well, and that co-design effort between Munich and San Jose, Munich and Sunnyvale, really enabled us to actually architect the system precisely and perfectly really well.
So math and the AI team in Germany, the silicon chops are here.
And the compiler team is in Germany, and these two teams work so cohesively, so really well across the time zones that we actually in some cases have what's called a live portal. So think of a Google Meet that's up and running 24/7 between our two sites. So anybody can get in front of a camera and say, hey, listen, can you answer this question? And that's the beauty of...
It's like video Slack.
Video Slack, with thank you to companies like Juniper and Cisco that made that possible.
Well, congratulations. I like how all this is leading up from your career. Obviously the success of Juniper is well documented. Now they're part of HPE. Congratulations, and we'll definitely do a follow-up. This is going to be a hot area when you look under the hood in these AI factories. Certainly they're going to be smaller, distributed, big, small, everywhere.
So thank you, John. Thank you for the opportunity. Like I said, I've been a big fan of theCUBE, and I've seen your videos over many years. I can tell you that for sure. And thank you for the opportunity, because as a startup, we need to somehow get our word out there, and folks like you make that difference.
Well, we love deep tech, we love startups, we love entrepreneurs, and it's hard. It's a hard task. People think it's great and easy. I want to be an entrepreneur. You don't want to, maybe not. Reconsider, it's hard, especially doing silicon and doing
systems and silicon.
Systems is hard. It's not easy. You can't vibe code your way to a new chip.
No, you have to be, no, you're right. You have to be dogged about it, and you have to be, you have to have patience. Patience is and relentless, but patient at the same time.
Well, we'll do a whole founder feature with you. I want to really talk more about that because there's a lot to share. I mean, entrepreneurship's changing.
It does.
The global economy is changing. You're starting to see a fully global distributed internet now with AI, so it's going to be super great. And sovereignty is a huge topic as well. So
and I believe our Tensordyne Napier system is well set up for the future. The proof is going to be in the pudding. You know, we have to deliver this to the market, and we have to get customer validation, and those are important things for us.
Stay humble and focus on the product, get a great product out there. We'll see. Looking forward to following. I'm John Furrier with theCUBE here in Palo Alto, the heart of Silicon Valley. Of course, we have our NYSE CUBE studios connecting Silicon Valley and Wall Street. When it comes down to deep tech and economics, that's the story of the technology industry. Technology is the market, and of course, we're doing our best to bring you the action from the startups to the public companies. Thanks for watching.